Good morning, everyone. Thank you all for joining today. Today's session is on the basic pedagogy of science. In this session, we'll explore the various techniques for teaching science effectively in your classrooms. We'll cover key concepts, innovative teaching methods, and how to make science both engaging and accessible for your students, especially in environments where resources may be limited. Welcome everyone to this exciting journey into the world of science teaching. I'm thrilled to have you all here today as we embark on this adventure together. Science has the power to ignite curiosity, spark innovation, and change the world. And as teachers, you are the forefront of making that happen. Today, we are not just learning how to teach science, we are discovering how to light that spark of curiosity in each of your students, whether it's through hands on experiments, engaging discussions, or exploring the natural wonders of our world. You have the incredible opportunity to inspire the next generation of scientists, thinkers, and problem solvers. So let's dive in with enthusiasm, with an open mind, and a shared passion for making science come alive in our classrooms. Welcome aboard. So, before we dive into the core content, let's take a moment to go over our objectives for today's session. These will guide our journey and ensure we stay focused on what we want to achieve. By the end of this session, you will have the understanding of the principles of effective science teaching. You will learn strategies for engaging students with limited resources in rural environments where teaching students with limited resources can be challenging, but it also offers unique opportunities for creativity. We'll discuss ways to captivate your students' interest no matter what the constraints are. And sometimes the most effective teaching tools are the simplest ones. You will learn how to create and implement easy to make aids that enhance learning and understanding. Then science is not just about memorizing facts, it's about questioning, exploring possibilities, and thinking critically. We'll focus on methods to encourage this mindset in your students. Then we learn how to incorporate simple virtual labs into your lessons, which are an excellent way to bring complex scientific concepts to life. We'll cover how to integrate these tools into your teaching effectively. Let's keep these objectives in mind as we move forward. Now, as teachers, our mission goes beyond simply delivering information. Especially in science education, we have the unique responsibility to shape how our students see and interact with the world around them. With that in mind, here are the key goals we aim to achieve through science. So our first goal is to ensure that students are scientifically literate. This means they can understand and use scientific concepts in their everyday lives, making informed decisions about the world around them, whether it's interpreting data, understanding environmental issues, or appreciating the role of science in our society. Scientific literacy is crucial for an empowered citizenship. We want our students to ask questions, explore, and learn through investigation. Inquiry based learning puts students in the driver's seat of their own education, allowing them to actively engage with scientific concepts rather than passively receiving information. Now, as we discussed, science education should sharpen our students' ability to think critically and solve problems. We want our students to analyze information, evaluate evidence, and come up with innovative solutions to the challenges they face. And lastly, it's important for students to understand the nature of science itself, how scientific knowledge is developed, tested, and refined over time. This understanding helps demystify science and show students that it's an evolving, dynamic process shaped by evidence and experimentation. Now, as we navigate the challenges of teaching science, especially in rural environments with limited resources, It's essential to leverage the tools that can enhance the learning experience. So on this slide, you can see some of the most useful teaching tools you can incorporate into your teaching lessons. So we have the whiteboard, which is a classic, but an incredibly versatile tool. It's perfect for explaining concepts in real time, drawing diagrams and science, and engaging students with interactive activities. It's also a great way to collect and display student input during your lessons. Then slides, as we discussed in our previous webinars, are an excellent way for structuring your lessons and keeping the flow of your information organized. Then visual aids such as charts, diagrams, and models can make abstract concepts more concrete and easier for the students to understand. Videos can bring the dynamic elements of science into life. So whether it's a documentary clip, an experiment demonstration, or an animation explaining a concept, videos can capture students' interest and provide a richer understanding of the subject matter. Then we have the virtual labs, which is a powerful tool, especially when physical lab resources are unavailable in rural environments. They allow students to conduct experiments in a simulated environment, exploring scientific concepts. Virtual labs can be used to reinforce lessons and give students hands on experience with the scientific method. Each of these tools serves a specific purpose in your teaching toolkit. By combining them thoughtfully, you can create a varied and an engaging learning experience that caters to different learning styles and keeps students actively involved in the lesson. Now, the first component of science teaching is lesson planning and execution. So, creating an effective lesson plan is the backbone of your teaching. It's not just about what you're going to teach, but how you're going to teach, ensuring that every student walks away with a good understanding of the topic. Let's break down the key components of a lesson plan. So, first one is the objective. Start with a clear objective. What do you want your students to learn by the end of the lesson? This could be a scientific concept, a skill, or an understanding. Your objective will guide the rest of your lesson plan, keeping you focused and ensuring that every activity aligns with your teaching goals. Next, list out all the materials you'll need for the lesson. This might include textbook, visual aids, then lab equipments or digital tools like slides and videos. Having everything prepared in advance ensures that the lesson flows smoothly and that you can focus on your teaching. Then the heart of your lesson plan lies in the procedures. This is your roadmap for how the lesson will unfold. Break down the lesson into manageable steps from the introduction to the main teaching activities and finally the conclusion. Include specific instructions for each part, considering how to introduce new concepts, facilitate activities, and guide students through learning tasks. Finally, always include a method to check for understanding. This could be through questions, a quick quiz, or a hands on activity where students demonstrate what they have learned. It's important to gauge whether students have grasped the key concepts before moving on. If there are any areas of confusion, this is your opportunity to address them and ensure that every student is on the same page. So by carefully planning each of these components, you can deliver lessons that are structured, engaging, and effective. Now here is a sample lesson plan for the topic water cycle, which is designed to teach students about the water cycle, a fundamental concept in environmental science. So here's how you can structure this lesson. So the objective of this should be that the students should understand the stages of water cycle: evaporation, condensation, precipitation, and collection. Then by the end of this lesson, they should be able to explain each stage and how they interconnect to sustain our planet's water supply. Then, and the materials needed, you can need visual aids, which are crucial for helping students visualize the abstract concept of water cycle. Then for like having a hands-on activity, you may need like plastic wrap, paper cups, and string. So these are the materials which can be easily available at their place. And this practical demonstration will help students grasp how the cycle works in the real world. Then the next is the step-by-step procedure. So start with a discussion of each stage of the water cycle. Use the visual aid to guide the discussion, ensuring that students can follow along as you explain each stage. Then with the materials listed, create a mini water cycle model. For example, fill a paper cup with water, cover it with plastic wrap, and use string to secure it. Place the cup in a warm, sunny spot and observe what happens over time. Students will see water evaporates, then condenses on the plastic wrap, and eventually fall back into the cup, simulating precipitation. Then, to assess student comprehension, provide them with some questions about the water cycle. So, these questions can cover the stages, the processes involved, and the significance of water cycle in the environment. This will help reinforce the learning and give you insight into any areas that may need further explanation. Now, I would like to discuss the 5 e-learning model, which you can incorporate when creating lesson plans. And this is a widely recognized instruction framework that helps structure science lessons in a way that encourages active learning and deep understanding. So we have the 5 E's in this lesson plan, in this learning model, which is the engage, explore, explain, elaborate, and evaluate. So let's break down each of the 5 phases with an example of the science lesson on photosynthesis. So let's start with the engage phase. So the goal here is to capture students' interest and get them thinking about the topic. Example, start the lesson by showing students a time-lapse video of a plant growing or a series of images showing plants thriving in different environments. Ask an open-ended question like, what do you think makes plants grow? This phase is all about stimulating curiosity and connecting the student to the topics of their prior knowledge. Then we have the explore phase. In this phase, students get hands-on experience with the concept. Have the students observe what happens to a plant when it is deprived of sunlight versus a plant when it receives sunlight. Encourage them to record their observations. This hands-on investigation helps students gather evidence and begin to construct their understanding on the topic of photosynthesis. Then in the explain phase, here you clarify concepts, introducing key terminology, explanations based on the student's experiences in the explore phase. After exploration, explain the process of photosynthesis, including the role of sunlight, water, and carbon dioxide in producing glucose and oxygen. Use diagrams and simple language to ensure all students can follow. Link the explanation back to their observation. Remember how the plant without sunlight started wilting. That's because it couldn't perform photosynthesis to produce the food it needs to survive. Then we have the elaborate phase. This phase allows students to apply their new knowledge to different but related situations, reinforcing their learning. So challenge students to think about how photosynthesis might be affected in different environments, such as deserts or underwater. You can introduce concepts like adaptations and ask students to imagine how plants might survive in extreme conditions. This not only deepens their understanding of photosynthesis, but also broadens their thinking about plant biology. Now, finally, we have the evaluate phase. And it involves assessing students' understanding and the effectiveness of the instruction. Have students complete a short quiz or give them some questions, or give them a reflective activity where they can explain the photosynthesis process in their own words or draw and label a diagram of it. You can also ask them to design an experiment to test a new question related to photosynthesis, like what happens if a plant gets too much water? This assessment can be both formal and informal, giving you insights in their learning areas and areas that might need further reinforcement. Now let's move on to the next strategy, which is the I do, we do, you do strategy. So this is also a powerful instructional method that helps students gradually develop the skills they need to work independently. It's a gradual release of responsibility from the teacher to the student, ensuring that they have the support they need at each stage of the learning process. Now, let's break down how this works with an example of teaching the concept of gravity. So here I do is the modeled phase. And this phase, the teacher demonstrates or models the concept or skill, showing students exactly how to approach it. Like begin by explaining gravity in simple terms. Gravity is the force that pulls objects towards each other. It's why when you drop something, it falls to the ground. Then the we do phase is the guided phase. In this phase, you guide the students as they practice the concept or skill together with you. It's a collaborative effort where you are still leading, but they are starting to get involved. Now make the students conduct a simple experiment with you. Ask them to do experiments with different objects like a stone, a leaf, and a piece of paper. Have them predict which will fall faster or slower, and then test their predictions by dropping the object. As they do this, ask guiding question. Why do you think the stone fell faster than the paper? What might happen if we crumple the paper? This phase allows them to apply the concept with your support, deepening their understanding through hands-on practice. Then we have the you do phase, which is the independent phase. So in this final phase, the students take full responsibility for applying what they have learned, working independently to demonstrate their understanding. Ask students to design their own experiment to test gravity with objects they find at home or in the classroom. They should predict the outcome, conduct the experiment, and explain their findings to the class either through an oral presentation or written answers. Now let's move on to the interactive teaching methods which can be employed in your science teaching. So let's start with the open-ended versus closed-ended questioning. So to stimulate critical thinking and encourage students to explore concepts more deeply, you can use the open-ended versus closed-ended questioning. So you can ask closed-ended questions like, does water boil at 100 degrees Celsius? Then you can ask open-ended questions like what factors could cause water to boil at a temperature higher or lower than 100 degrees Celsius. Now, while teaching about the states of matter, start with close-ended questions to check basic understanding. Then transition to open-ended questions to encourage students to think about how pressure and altitude can affect boiling points. This gets students thinking beyond the basic facts and into real-world applications. Now, next method is the Socratic questioning method. So the purpose of this method is to encourage deep thinking through guided questioning that challenges assumptions and uncovers underlying concepts. So when discussing about ecosystems, instead of providing direct answers, use Socratic questioning. Why do you think the population of predators affects the population of prey? What happens like if one species is to be removed from the food chain? This method helps students develop their reasoning skills by making them justify their thoughts and explore the deeper implications of their answers. It's particularly effective in exploring the complexity of ecosystems where interdependence is a key. Then make use of stories and analogies to make scientific concepts relatable and easier to understand by connecting them to familiar experiences. Like, for example, you can use an analogy like the cell membrane is like a security gate that controls who enters and leaves the cell. This can be used to explain the function of the cell membrane in a biology lesson. Then we have the next method we have is the group work and cooperative learning, which can promote collaboration and peer learning where students work together to solve problems or explore concepts. So, like if they are performing any activity, each of the students, you can group the students, like divide the students into groups and like assign each group like a different stage of the water cycle. Like each group researches their stage and then teaches it to the rest of the class. So if they are performing any activity in a group, one of the students can get the materials whichever they can. One of them can do the visual part, drawing and all, and the other one can perform the activity likewise. So this ensures that each student contributes to and learns from a group with a focus on mutual responsibility. Now, in this activity, we are going to create engaging science stories based on the science concepts. So here are the visuals of two scientific concepts, the photosynthesis and the water cycle. So I'll show you how you can create a story for a science concept. So let's start with the photosynthesis story. So once upon a time, there was a little leaf named Leela. Every morning, Leela would wake up to the gentle sunlight. She loved how the sun rays warmed her surface and gave her energy. Leela knew she had an important job to do. She was a part of a big tree, and she needed to make food for herself and her tree friends. As the sun shone down, Leela would use her green chlorophyll to trap the sunlight. She would then mix it with water from the soil and carbon dioxide from the air to create something special, glucose, a sweet treat that fed her and helped the tree grow tall and strong. But Leela wasn't selfish. She also released fresh oxygen into the air, which all the animals and humans needed to breathe. Every day she felt proud to be a part of this magical process called photosynthesis, knowing that she was helping the whole world thrive. So now I want you to create a similar story for the other concept which is given over here, water cycle, considering water drop as the main character over here. So with the help of these stories, you can create an interactive and an engaging class, and the students are more likely to remember and retain the concepts better. So now let's dive into the heart of science teaching, hands-on activities and experiments. So these hands-on activities are essential in science education because they allow students to explore and understand concepts through direct experience. When students perform experiments or build models, they aren't just learning passively, they are actively participating in the discovery process. This engagement deepens their understanding and retention of scientific concepts. You can see here a lot of hands-on activities which the students are performing. Now, I would like to introduce an exciting tools that can greatly simplify how you gather and organize resources for your science experiments, the Experiment Resource Chatbot. So this chatbot is designed to provide you with everything you need to conduct a successful science experiment. Whether you are planning a classroom demonstration or an at-home activity, this tool will help you streamline the process. So you just have to enter the topic or concept you want to explore and for which grade level. So here you can see I have written here water cycle for grade 6, and it has listed me what the materials are needed, what are the steps, even the explanation, and you will also get the song or a rhyme to memorize, which can help the students to memorize about the water cycle. So the advantages of this chatbot are that you don't need to search multiple sources. The chatbot compiles everything for you. And you can tailor the experiment based on the materials available to you, and the chatbot will adjust the instructions accordingly. So the chatbot eliminates the need for lengthy searches for reliable experiment instructions. So explore this chatbot. Now here we are going to discuss the power of collaborative learning in science education. So it isn't just about the students working together. It's about building on each other's ideas, sharing responsibilities, and developing communication skills while they learn. So you can see here in the video, this activity was conducted to make a model of lungs. So the students were divided into groups, and each of them were given a responsibility. They decided amongst themselves who would do which work, and you can see how beautifully they are presenting their models. Now let's see the concept of virtual labs and how they can be an essential tool in your science teaching toolkit, especially in rural and resource limited environments. So these virtual labs are interactive, simulated environments that allow students to conduct experiments online. They mimic real-world science labs but are entirely digital. So in a virtual lab, students can manipulate variables, test hypotheses, and observe outcomes just like they would in a physical lab. So as volunteer teachers, you will be teaching students in rural areas where access to well-equipped science labs is often limited. In many cases, schools may lack the necessary materials and infrastructure to perform physical experiments. This is where virtual labs become incredibly useful. So imagine teaching a class about chemical reactions in a rural school where there's no access to lab chemicals or safety care. Instead of skipping the practical experience, you could use a virtual lab that simulates the reactions. The students can still mix virtual chemicals like you will be doing on your screen, and the students can observe the experiment going on. They can observe reactions and note down their results just as they would do in a real lab. There are many free and easy to use platforms you can explore. So you just need to set up this simulation, conduct the experiments, and then you can discuss the observations and results with your students. So I'll just show you a demonstration of a virtual lab, how you can run a virtual lab. So here you can see this virtual lab is for the pH scale to test the pH of various substances. Sometimes in our schools, we don't even have access to any of the equipments, any of the solutions and all that. So if you are teaching about pH, you want your students to know the pH of various substances. Here you can use this virtual lab. So you just choose what substance pH you want to test. Like here, I've chosen water. Here you have different substances present over here. You just take the pH probe from here and put it in this solution. Here you can see it is showing pH of 7. We even have an acidic and a basic separation to show whether the substance is acidic or basic. Now I can remove this pH probe. I can change the substance. For example, an orange juice. So I am filling my container with orange juice. Now I take my pH probe and just put it into it. And you can see the pH is acidic, which is 3.5. You can even show the effect of adding water. The pH is increasing, like the acidity is decreasing. Let's check one with a hand soap solution. So I've kept the pH probe in that only, and you can see the pH is in the basic range, the 10 pH. Now, if I add water to this, the pH is decreasing, it's becoming acidic. So I'll show you one more demonstration of a virtual lab So this is the virtual lab simulation of states of matter. You can see over here the arrangement of particles. So this is the solid state. Now, what happens if I apply heat, if I increase the temperature? You can see the temperature is increasing. So as the temperature is increasing, the particles move faster and they are changing from the solid state to the liquid state. So now what happens if I cool it, if I decrease the temperature? You can see on the temperature scale, the temperature is decreasing. So the particles, like from the liquid state, they again come back to the solid state. They are moving slowly. So this is just a little bit of a demonstration of a virtual lab. You can explore it. Again, this is the virtual lab to show about forces and motion. So here I can show the sum of forces, the values, the direction of the forces, and all that. See, the sum of forces is 50 newtons and the resultant force is in the right side. Now, if I put one more, so sum of forces is 0. Even on the left side, you have a force of 50 Newton, and on the right side, you have a force of. Now, if I increase the force over here, you can see the sum of forces is 150 Newton, and it is towards the left-hand side. So these are just some uh, virtual lab demonstrations. You can explore these virtual labs, and you can conduct these virtual labs in your classes. Now, next, moving on to how we can use MyViewBoard for science lesson. We have discussed about MyViewBoard in the digital tools for teaching webinar. So again, here we'll see how we can use it for our science lesson. So you have the embedded browser over there where you can run the lab simulations, just how we have done over here. There, like you can conduct live experiments, you can draw diagrams, you can annotate it and all. So I'll just show you a basic demonstration of how you can use MyViewBoard. So this is the MyViewBoard canvas. As we have discussed it earlier, it has an infinite canvas. So you can use this pencil over here to draw diagrams. Then you can use the text tool over here to annotate the text and all. Other than that, we have like the magic box over here, which has a variety of tools. So when you go to the magic box, here you have the integrated camera. If you just integrate this camera, your camera will be visible on this MyViewBoard canvas. So if you are conducting any experiment at home, you can be on the whiteboard canvas and still integrate your camera over here, and you can run the experiment over here. Then, for example, imagine here that you are measuring the temperature of water, and you need a stopwatch. You are measuring the temperature of water for every 2 minutes, and you are conducting at your home. You are boiling water at your home. You can integrate the camera from over here. You'll get a camera on the screen canvas of MyViewBoard. Then you can go to the math tools. Here we have a stopwatch option. You can put the stopwatch onto this canvas. You can put it at the place wherever you want to. Imagine you are having the experiment running live over here. Then you have the stopwatch. You can start running the stopwatch. Then you need a table to record your observations. You can go over here. You can put the table from over here, drag it onto the place wherever you want to keep it. And like, as I said, you are measuring temperature. So you need two columns, time and temperature in degrees Celsius. Now you can start the stopwatch. You can run it for 2 minutes. Notice the time and the temperature. You can like make all the observations over here. Now you want to plot a graph on the time and temperature. So again, in the magic box, we have the math tools, and from there you can take a graph over here. So basically, you can do all the things together at once. You can drag it over here. You can like run the experiment, keep the stopwatch, make a table to record the observation. Then you can even plot a graph using this My View board. Drawing, annotating, that you can do anyhow. You can, if you are logged in, you can use most of the features. Like you can use the YouTube feature over here. You can see Candlelog. Whatever you can search over here, you can run the experiment over here on this canvas only. You can see like the experiment will be running over here. You can drag it and keep it on the place wherever you want. Like again over here, like while the experiment is being running, you can record the observations, plot graphs, and so on. You can do a lot of things. So explore the various features of this My View board also. We'll be sharing the link of the use of science tools in My View board. So explore all these tools. Now coming on to the resource management and utilization. So it is one of the most important aspects of teaching science, especially in our resource limited environments. So we have to learn how to manage and utilize what's available. As volunteer teachers in rural schools, you may often find yourself in situations where access to standard lab equipment is limited. But this doesn't mean we can't conduct meaningful and impactful experiments. So it's quite the opposite. So let me share an example. In one of the rural schools, we didn't have access to Bunsen burner, which is typically used for heating substances in science experiments. So we had to heat a particular liquid. So students came up with a creative solution. They suggested we use a simple candle as a substitute for heating. So it was an incredible moment. You can see here how the students have kept the candle in a glass as its holder. And you can see the liquid is also like getting heated with the help of the candle. So it was an incredible moment to see how resourceful and inventive the students became when faced with challenges. So simple items like this can turn into valuable teaching aids, and your students will appreciate the creativity and effort you put into making learning accessible to them. So remember, your role as a teacher is not just to transfer knowledge, but to inspire and empower your students. So encourage your students to bring their own ideas for conducting experiments, and you'll see them come up with wonderful suggestions, just like this candle one. This will not only make the learning process more interactive, but will also foster ownership and responsibility in their learning journey. Now, it's important to ensure that our students grasp the concepts we teach. So, this can be done in many ways through quick assessments, projects, or even peer and self assessments. We can use a variety of tools to gauge understanding, but the key takeaway here is to make these checks interactive, fun, and aligned with the learning objectives. So these methods will help us see how well the students have absorbed the material and give them a chance to showcase their learning in a creative way. Now, giving feedback effectively is also crucial for helping students improve and stay motivated. Keep a few things in mind, like give constructive feedback, focus on growth areas, but also recognize strengths. Feedback should be clear and guide students on what they can do next. Then, even when criticizing, keep the tone encouraging. So, tools like student surveys and reflection exercises can also help gather student input and give them a voice in their learning process. Now, let's go over some key tips to make science teaching more impactful and engaging. So, be enthusiastic, keep it simple and clear, break down complex concepts, incorporate humor and storytelling, celebrate student participation and effort. So, as we are about to conclude today's session, I want to leave you with a thought from Richard Dawkins: science is the poetry of reality. So, this quote beautifully encapsulates the essence of what we do as science teachers. We aren't just sharing facts and formulas, we are revealing the profound beauty and harmony that exists in the world around us. So embrace poetry in science, encourage your students to question, explore, and find wonder in the simplest of the phenomena. Because when we teach science with enthusiasm and creativity, we show our students that the world is much more magical than they might have imagined. So thank you everyone for joining today.